Hello, this video shows you how to georeference handheld Lidar data from a forest environment. One method is using signal markers, which you place on the ground, measure those with GPS, and the software finds the signal markers based on intensity. And we solve an XYZ shift and a 2D rotation. The first demo uses Faro Orbis handheld LiDAR data, which comes in with coordinates relative to 0, 0, 0. I read in the point cloud. Coordinates are close to 0, 0. We have intensity in the point cloud. I have also brought in a trajectory solution. And I use fit using targets, select automatic ground signals, and ask the software to find 3 best matches. 3 most potential signal markers locations based on intensity in the point cloud. And I check, are these real findings? The first 2 are real signal markers, but the third one is not. I remove that one. I read in a text file, which is the target coordinates. 500,000 easting, 6.8 million northing. And I look at the residual, what remains after a XYZ shift and 2D rotation. Now the data should be in the right positioning, and I read in drone LiDAR data just to verify. And everything seems to match nicely. Another method for georeferencing is using trees. The software can find potential tree locations in the handheld and in a reference airborne point cloud, and solve a shift and 2D rotation based on the potential tree locations. Combining handheld and airborne LiDAR makes a lot of sense. Handheld doesn't necessarily see the tops of the trees, and the airborne can give us better information for the height of the trees. And the airborne, of course, has good positioning. When I have merged those, I would remove all the airborne points except the high ones, maybe above 15 meters above ground. The second demo uses the same Faro Orbis handheld LiDAR data and drone LiDAR, a yellow scan mapper. I read in again the Faro Orbis 00 based point cloud. I apply an ad hoc XY shift so that I get the coordinates to be somewhere in the right neighborhood, and both my point clouds are visible on the same screen. I read in the drone LiDAR, which is in the projection system coordinates. And now they fit on the same screen. And I will use fit to reference using trees. So the software will find potential tree locations in the 2 point clouds and solve shift and rotate based on the potential tree locations. And everything looks visually good in a cross section. And then I just show how I would remove the unnecessary airborne data from the area for which I have the handheld data. So I would keep the yellow scan data only above 15 meters. My last demo shows the same thing, but now using more sparse airborne data, National Land Survey data, 8 pulses or about 16 points per square meter. I read in the same Faro Orbis data, apply the same ad hoc shift, and get the handheld data somewhere close to the right positioning and fitting into the same coordinate setup. I read in as the reference now sparse airborne data, and I use the same fit to reference using trees. Same settings, click OK, and the software solves the positioning. Thank you.